Good morning, friends. Now, previous session we have seen the force analysis of worm gear. In that, three forces are there. Basically, for worm and gear, totally 6 forces are there, 3 each. So I told you the structure, how this calculation we have made, how these formulations for the axial, tangential and radial load. So according to that, we have also seen the similarity as I have mentioned over here. GT is equal to FWA, equal and opposite force, that I told you. Now we'll start with the numericals on force analysis. As I told you, I'll cover the numericals because the remaining gears which we had seen, spur, helical and bevel, in syllabus they have mentioned theoretical treatment only for the force analysis. Now the worm gear is the gear on which the numericals will be asked on a force analysis. So I'll read the problem and will explain from my side how to solve the numerical stepwise. So you can see, I'll read the problem. The worm gear pair having designation 2/60/10/6. So as I told you, this is the designation. First digit always indicate number of start on worm, second digit will be the number of teeth on gear, third digit will be diametral quotient, and fourth one is a module. If there is a fifth one, that would be center distance. So worm gear pair transmit 5 kilowatt power from worm shaft rotating at 1440 rpm. Now power is given, that is transmit from the worm, that is input power. That's why Pi is equal to 5 kilowatt we have taken here, and then the power from the worm shaft rotating 1440. It means the rpm of worm NW. Then the worm is left hand typed. Of course, if it is left hand and rotates in an anti-clockwise direction as it is viewed from right side. So this condition is only for the drawing the forces. For that purpose they have given. So at the end of the numerical, we'll have to draw the diagram of the force analysis, where which direction force will act. For that, this condition they have given, and left hand thread they have suggested for worm. Correct. The coefficient of friction between the worm and worm gear pair is 0.05. So I have mentioned here coefficient of friction 0.05. While the normal pressure angle, of course this is phi n, 20 degree determined. First one is a component of the forces of the worm and worm gear. It means 6 force, tangential, radial and axial. For worm and worm gear we need to calculate. Clear? Now second one they have asked for the efficiency. Third one they have asked for the power lost due to the friction. Power lost due to friction is nothing but heat generation. So we'll see. Now first of all, I'll calculate the component of forces as they have asked. The step number 1 is to calculate the terminology, basic terminology which are required to solve the numericals, that we are going to calculate. Now you can see step number 1. I have calculated here dW, that is diameter of worm, is equal to, we know, m into q, because q is equal to dW by m. So m module is given 6 and q is 10, diametral quotient. It will give value of 60, that is dW. Now next one be the dg, diameter of the gear. Here what we say, m into zg, mass module is given, and zg, number of teeth also given, so it would directly come 360 mm. Now we need to calculate, as I told you, the terminology. So I can use the equation tan of lambda is equal to ZW, number of start divided by diametral quotient. Number of start is 2, diameter quotient is 10, so lambda is 11.31 degree. That will be the lead angle. Now these are the basic terminology, students. So that we need to calculate first. That's why we are doing this. That would be our first step always in case of the worm gear. Now velocity, that is pitch line velocity of worm gear. Of course worm is there, that's why dW and NW is in picture. So I have written over here into 10⁻�3, which will gives you the meter per second value. So here I got a 4.52 meter per second velocity. Now the phi v, as I told you, this will be the friction angle. So friction angle tan phi v is equal to mu v, and mu v is nothing but mu by cos of phi n. I also told you directly, you can see phi v is equal to tan inverse of mu v. So mu is nothing but coefficient of friction 0.05, and friction angle cos phi n, it will gives you cos 20. So friction angle would be phi v is equal to 3.0457 degree, correct. So these are the basic terminology. Now we'll move toward the force analysis, first part, that is tangential force. FWT for worm, that is P by velocity, of course. So P is nothing but the input power generated by the worm, that is 5 into 10 raised to 3 divided by velocity. We have calculated this 4.5 here. So by putting this, I'll get the FWT value is 1105.26 Newton. As I told you, equal and opposite force, we know the diagram. That's why this balancing force is tangential force of a worm is always equal to axial force on gear, correct. This will be the first part. Second will be the axial force on the worm. So FWA, we know the equation, A is equal to FWT divided by tan of phi v plus lambda. So purposefully we have calculated the phi v 3.05, I put here, and 11.3 for lambda. So that also value I kept here. I'll get the axial force 4318.5 Newton. It is always equal to, from the diagram, FGT, tangential force on gear. Now last force is radial force. We know the equation, FWR is equal to tangential force into tan of lambda divided by tan of phi v plus tan of lambda into tan of phi n, pressure angle, that is normal, divided by sine of lambda. Just put the value, we know all the things. So directly by putting the value, many times what happened, the students are calculating tan phi v. No, you just calculate phi v and just use it, clear. So from this we'll get the radial force on the worm is equal to 1620.2, which is equal to radial force on gear, equal and opposite toward the center, correct. So first parameter we have covered as they have expected, that is component of the force. Next one is they are asking for to calculate efficiency. We know the efficiency is equal to tan of lambda divided by tan of phi v plus lambda. All things we know. The efficiency will be, I have written here, 78.14. So 78.14, correct. So this will be the, that is 0.78. So second part is over. This will be the efficiency. Next, third part, they have asked to calculate power lost. As I told you, power lost is nothing but heat generation, and in heat generation I told you that Pi minus Po, you can see Pi minus Po, input power minus output power. So output power is nothing but efficiency is equal to Po, output power by input power. So Po is equal to efficiency into Pi. So I put here. So this value again Pi get common and I'll get the equation Pi into 1 minus efficiency, that would be always power lost. You can directly use this equation. So efficiency we have calculated, that is 0.78, and through this the power lost of the system 1.09 kilowatt, clear. This likewise we need to solve the numericals related to the force analysis. Before that, see, this is also the diagram we need to draw. This will ask for 2 marks. It will give the indication whether you are clear from your side or not. You can see, I'll explain. The left hand thread gear is there and here worm is there. Now while doing this, I always told you in terms of the analysis, force analysis, the tangential force is always opposed to the worm. So this will be the worm structure. See, it will be the rotation anti-clockwise and FWT is in this direction. So by that way you can change the direction, that is worm FGA. Radial force of course equal and opposite toward the center, and tangential force is always equal to axial force of worm. Likewise you can draw. That's why they have mentioned left hand thread with anti-clockwise rotation, clear. So please check that rotation, and from that statement as I explain you here, see, anti-clockwise direction and viewed from right and left hand thread. So on the basis of this we need to draw the diagram. If possible you can write here values which you have calculated as like FGA, FWT and so on. So better you write here. So such kind of the procedure we need to follow for solving the force analysis numerical. I hope you understood the numerical, their steps. You need to try from your side also. Okay, next point we'll see in coming lectures. Thank you.